Hello, and welcome back to Survivor Man show, Naked and Afraid, Survivor. And my name is Bag Reels, and I will be your host today. We will be hunting down the mysterious species known as Conic sections. As you can see, there's some tracks left behind by our first specimen, the circle. Let us begin. Now, we are going to talk to our scientist for the show today, Dr. Palmer, who happens to be an expert on conic sections.
Hey there. I know quite a bit about conic sections, and they're so fascinating. They're my favorite mathematical formulas. Now let's get through them. Today we will be talking about the circle. This is the basic equation for a circle. It is so elegant and beautiful. X squared plus y squared equals r squared. And this is a sample problem for you. You can read this as you have to set this equation equal to 0, which would make it 3. And this one equal to 0 as well, which would make it negative 2. These coordinates give you the center point, which is listed here for your viewing pleasures. This is the radius. It is square rooted, and you get the radius. Now we will graph this. So 3, negative 2. That's our center. Unlike other conic sections, a circle does not have foci or vertices as it is a circle. And so now you put points 5 points away from it, right here, right here, and somewhere around here, and like right here, and then you just kind of connect them and get a circle.
Wow, that is truly amazing, Dr. Palmer.
Thank you. Not time for tutorials, Carl! Circle, not a Billy!
Circle.
I have gotten my scouting point at the top of this tree, and now I scan to find the amphibious ellipse. As you can see, I've got it in my sights. I believe I got it. It's right there in that creek. Let's go, Arthur.
Hello, and we will be talking about ellipsi today. Now, contrary to popular belief, this is the correct spelling of the word. And this is the basic formula for ellipsi. You can find the center point from the x squared and the y squared together, just like a circle. And these are its minor and major axes, which act like radii from a circle. So most of you already know about this. The only major difference is this number has to equal 1. Now we will graph this. We want you to graph this using foci and minor and major axes, but we won't do this in this video as it is too complex.
Excuse me, Dr. Palmer. Is there any sort of union or group that wants you to graph it with foci?
I believe it is a math teacher's unit. Now it's time for Cooking with Carl! Ellipse! Ellipse! Smash! Now to Billy!
Hello, darkness, my old friend. I've come to talk with you.
Bear Grylls does not fall. He descends at a quick pace. All control, dear. That was nothing. No tree can withhold me. A wild parabola identifies and copies the attributes of tree branches. So although it is an aerial creature, there's one now! As you can see, it looks identical to a tree branch. That's only because it's copied the attributes. It is aerial, so it does rest on tree branches. Hides from predators. Let's zoom in on one now. What a mystical creature.
We've been in ghillie position for 12 hours.
And as you can see, we haven't had very many results yet. This tree is known to attract the wild parabolas. Oh, I think I see one now. Are you ready? We must get this on footage. I'll shoot one down. Must get my sights right on it. Can't miss this one. This is a large one.
Today we will be talking about parabolas. This is the basic equation for a parabola. And this is the vertex or standard form, depending on the way that we are plotted. This is an XY table which aids in graphing, but it's completely unnecessary. And this is how you find the vertex. Now I will proceed with graphing this. Alright. Here's the vertex. And instead of using this table, you just kind of make lines come out of it up or down, depending on the A value.
Excuse me, Mr. Palmer. Is the XY table required by the teachers' union?
Yes, the math teachers union made it up, but I do not see a use in it.
Thank you for your time.
We make you use it!
Car ride with car! Parabolas! Up, down, right, left, now to Billy!
Parabola.
Alright, then the last conic section we're hunting for is a lot easier to find, considering it is not a moving membrane. Although it is a living creature, it is a plant that goes through photosynthesis. Photosynthesis! Okay, so now, I believe I found one here. Do you see that tree? How it crosses? There is a parabola on top as well as bottom. That's how I like to identify them. That is a hyperbola. If you were to get two parabolas and put them back to back, either going up and down or side to side, you could see what a hyperbola is. Just like that membrane there.
Thank you. Today we will be talking about hyperbolas. The equation is really similar to an ellipse, except with a minus sign. As you can see, this is very complicated, so it was already done for us. Basically, you use these to make a box from the center, and then you drew asymptotes through the center and the corners of the box. Now, excuse my poor handwriting, but this is what it will look like. These are asymptotes, and you may have to find the equations of them. Now, to find out which way the hyperbola opens, you use this value in front of the minus. In this case, it's horizontal. You start from here and you go woo, and then same thing on the other side. This is called a vertex, and this is a covertex. Now, you know how to graph most of the conic sections.
Now time for Creeping with Carl! Hyperbola base. Now to Billy!
Hyperbola.
Now it's time with Cooking for Carl! Ellipse!
Hello, darkness, my old friend. I've come to talk with you again.